Good evening, everybody. It's Chris West.
And Jim Bradley, hello.
How y'all doing? And it is in time once again for House Calls Vermont, the weekly building science show for all people, but mostly for regular people, not people who are architects or builders, but architects and builders often get a lot out of it. And this week we have an interesting show for you. Jim and I will be talking at the beginning. First, some news, some updates. We'll be talking about the tiny house, but after that, we're going to be talking about heating systems. What kind of systems are there? What does a heating system look like? What are the components of a heating system? And what are the options? And some of the things do heating and cooling. But we'll go through all those. Then we'll get a update on 10 Old Stage. What's going on over there, talking about ripping off some of that exterior siding and seeing how little structure was actually under the outside of that porch. Eek! Then we're also going to have a bit doing the first part of an audit that Jim and I did this last weekend on a house from 1909 over in Barre. So we'll take a look at that. And at the very end, we have today as an addendum, as an addition, as a value plus of the talk about heating systems. I have a discussion with Deva Racusin from New Frameworks. We both took the class on integrated heating systems from Robert Bean on HeatSpring, a very intense course. And one of the things that was all about was about radiant ceilings. So we're going to talk in our interview. We talked about radiant ceilings because he's actually installed them, and so I pick his brain about that, and that'll be the show for today. But to start with, let's just get to some news. So I want to just start off with and that's like covering my face.
Where's that? Where's the Chiron? Where's the drum roll? I mean,
drum roll. So
these special effects we got to work on, Chris.
Yeah, I know. I'm still doing this on my own here, so we're working on that. I have someone who may be coming in to do the tech stuff, so it'll go a bit more smoothly, hopefully. But to start with, I got a call today from Rob Comboy. You guys may remember Rob Comboy. I did an interview with him about 5-6 weeks ago. He's the president and owner of Glavel Incorporated. It's a vitrified glass insulation that's used below grade. It has unique properties, including that it's compactable, it's drainable, and even when it's got a water table against it, it's still about an R1.3 and sometimes as high as 1.7. So instead of having gravel and a plastic insulation, you can swap those both out for this product, and you can then be getting plastic out of the stream. And the factory is right here in Essex, Vermont. And so what we want to announce is that today I got a call when Rob was saying from the 13th to the 17th of September they're going to have an open house. It's not an open house. I'm sorry, they're going to be doing tours. I think it's too dangerous a place to have an open house. Everybody running around with this oven baking recycled glass.
Hey, Chris,
yeah.
You only have to get one burn to teach 1,000. So, it'll be safe.
Just let them run up and touch the kiln. Yeah, great idea.
Yes.
So as of Friday this week, there will be a sign-up sheet or more information. Let me just put it that way. I'm not sure how they're going to do this yet because I haven't seen it myself. But starting Friday, their website, glavel.com, will have information about when the tours will be happening, and you can sign up for those. And we have been asked, Jim and I have been asked to do a live broadcast for them. Yay! So we're going to...
Yeah, so no longer just a face for radio or YouTube. It's actually in person. So we're still deciding on what costumes to wear, so be prepared.
Well, my son Sebastian turns 20 today, and yesterday Anita and I went to Party City to get some balloons, and they had all of this themed stuff. So we got a Mario Brothers themed thing. Yes, including. Let me show you this. Just a second. This is awesome.
This is all energy related, everybody. Just rest assured. Oh my gosh. Give me the hammer. I want the hammer. Lovely.
So including this is the pinata, right? So
Yeah.
including and Lucas was saying you have to hit it with your head in order to get the stuff out. So we'll look into that.
I have a comment. Is that the first real beatbox then? A
Ooh,
pinata? Oh, see?
ooh. Okay, so we'll be bringing you updates on the Glavel thing as things are progressing towards that place, and we will keep you up to date, and we will let you know when we will be there. Which I probably, if we can manage it, that opening Monday may be the best time. But Rob may have other ideas, so we'll coordinate with him. So that's great news. That means that as of the middle of September, you will be able to get Glavel, locally produced Glavel, and not have to ship it in, in cartons from across the street.
Is the name still called Glavel though through them? So is it, or is
It's Glavel Incorporated, so
Perfect.
all their branding is Glavel. So I think.
Did they ever get to the point, Chris? This is an interesting question, and we can ask Mr. Convoy about this. Is the embodied energy of that product? What does it take to actually process this? Because right now we're repurposing materials,
Yep.
which is great, and it's not just going in the landfill, and it's a great use for that and all the extra benefits. So I wonder if they did a cost analysis yet, and I'm sure they have, compared to their product and getting it to site as compared to the gravel and plasticized installation, and what those effects would be. That'd be great to know that.
Yeah, and I'm sure he has an answer to that, and
Sure.
I'm looking forward to hearing it.
Yeah.
So that's the Glavel thing, and we also wanted to just quickly talk about the tiny house. So I've got a graphic here. Let me just get my graphic up and running. The tiny house graphic. Okay. And why is it not coming up? Oh, I did something wrong. Give me just a second, guys. I do have the graphic. There it is. Okay.
Chris, what we did, everybody, is that we did a story originally. We first went out on a home performance assessment for a couple that had done this stellar show on how they were moving into this tiny house. They were a young couple, both professionals, and this was their first home. They want to be minimalistic in their housing expense and everything else and their footprint. So they went with a tiny house and were showcased on HGTV. Wonderful out of the box, looked really, really great. But then things went really sour, really south, really fast. Within 3 years, they were noticing mushrooms in the kitchen that they didn't buy. They were growing freely through the walls. And with that, they then called us in, found that there was a lot more problems. And it was all about that building science was ignored.
Yeah.
It was ignored. You can ignore building science, but building science won't ignore itself. And it's going to create problems. And so with that, they finally had such a bitter taste in their mouth about all this after we did a story through Journal of Light Construction on this.
Yeah, and I just brought that, by the way, up. If let me just, you can go, you can do a search on Journal of Light Construction. This is just the article itself, and that's the tiny house. This is a 280 square foot tiny house, and it was actually pretty nice. I mean, we thought, this is a nice place to live.
Yeah, the brochure pictures were wonderful, but then they ended up realizing that they didn't want to go through the whole gutting and the retrofit and everything else. And we tried to help them sell it on the open market, and it didn't go anywhere because no one wanted to take on the endeavor. But Chris and I said, listen, it's not about just finding the problems, it's preventing them from happening in the first place. As we say, preventing bad things from happening. And so we thought, what better way for us to utilize the subcontractors that we have, the building science knowledge that we have, our own sweat equity, and to do a showcase of this, a documentary, to be able to show people that how to do this effectively, how to do this right, because this translates not just for tiny house, Chris, of course, as we know, this is the mobile homes, modular homes, everything. How you do this effectively and giving proper adherence to and respect towards building science principles and getting that into place. So we're going to have this reoccurring show, and with different parts, and showcasing the different measures that we're going to be implementing. And one of those things we're going to be doing is the Luno system. Just for the energy recovery ventilator and the heat recovery ventilator, we're using the Luno system, which is offered by 475 High Performance Building Products. And this is a perfect setup to handle a space this small. So we're really looking for that to happen.
So the Luno system, I have it up on my screen.
Oh, wonderful.
So this is a really interesting. It's one of the ventilation systems we spoke about when we were originally doing the ventilation show when we were still on the radio, which we will again. We'll be back on the radio starting in October.
Yeah.
But when we were talking about ventilation systems, the Lunos is one of the ones we were talking about. And one of the things that's great about the Lunos is that it's very easy to to install it as a part of a retrofit. You just make a hole in the wall, you put it on, and you put one in one area, and then in another part of the house you put another one, and there are two fans, and they talk to
Push
each
me,
other.
pull me.
Yeah, they talk to each other, and one sucks for like 70 seconds, and the other one blows, and the other one sucks and it blows, and they move the air in and out across a core. You can see that here, this white ceramic bit here. That's the core, and though that's what traps or captures the heat and transfers it to the other stream. They're just doing this a stream in one direction, then a stream in the other. And these are great units. And we're very much looking forward to showing you the unit that was in there that was woefully underpowered and not very well thought out, and may have contributed to higher moisture in the space itself.
Yes,
But most of that was in the pan, right? It was way low. So
exactly.
so what we'll be like Jim was saying, we're going to be doing a full documentary on our retrofit, right? We're going to show you from step 1 to step 10, and we're going to tell you why we're doing what we're doing.
And the exciting thing, Chris, is the fact that we can now say House Calls is on the move, literally, because on Thursday, the house is being moved from its location in
yeah,
Burlington, Vermont, to Chris's, how would you say, business incubator at 10 Old Stage Road, where we're going to be placing this and doing the retrofit work. So we're implementing a lot of the state-of-the-art techniques and products and everything else, and making it just a different system than it was before, but yet still keeping the price point reasonable and effective, and making sure that what you're building is lasting, is going to be durable, but also that the building occupants are safe, good
yeah,
indoor air quality,
yeah,
excellent,
absolutely.
as far as that's concerned.
Yep. And there are lots of things that are in play there, and we're really looking forward to explaining why we're doing what we're doing, and what is a good way to look at building a tiny house, whether it's on a trailer or on a foundation. The smaller a house gets, the more concentrated your moisture is going to be. The more percentage of the square footage, two of the moistest rooms in a home are your kitchen and your bathroom are now, instead of being 1/30th of the square footage of the house, it's now 30%, right? Yeah, you're like completely reversing that. So this is going to be fun. We're really looking forward to that, and we hope you'll all join us. And by the way, we're going to also be doing it at 10 Old Stage in the backyard. So we're going to be inviting people to come along and take a look at what we're doing. So if you're in the area and interested, let us know, and we'll make sure to let you know when it's happening. So back to the topic of the day, however. Today we're going to be talking about heating systems, just to give everybody a good understanding of what a heating system is. And most of us know this, but a lot of people will point at a radiator and say, that's my heating system. And that's not wrong, it's just not complete, because a heating system is a number of components. So I found some great slides on the Department of Energy .gov website explaining this very clearly. So I'm just going to switch it over, and here we go.
Well, one thing, Chris, as you're doing that, the thing that just simplifies it all, we can just quote Tom Hanks from Castaway. I made fire, for how many millennia that people were relying upon for heating, just the fire, a big open fire, from even the Vikings, where they would have these open mound systems with a big hole in the roof and just start a big fire. And if you're in front of the fire, great. But if you're anywhere else in the building, the cold air is coming in to replace the warm air that's leaving that structure, and you would get cold. The thing is, though, fast forward to the 1800s and even a little bit earlier, they would have the fireplaces inside the house, multiple ones, and the same thing occurred. you had the fire going, and if you were within a close proximity, you would stay relatively warm. You leave that area to another part of the house, you were going to get cold because it wasn't even distribution. You didn't have great air sealing methods employed or insulation, and so anywhere in the outlying areas of the home, you would get cold again. So it's important to know what type of heating system will fit your home, and it's not just installing the right heating system, but it's also making sure the building is appointed appropriately at the same time.
Yeah, you're putting a heating system into an environment, and the environment is your house. I mean, the house that we were at, and I recommend you all to watch later in the program when we'll be having our audit eavesdropping. And later in the week, I'm actually going to take all of the audit eavesdropping videos and put them in their own playlists on our YouTube channel, so you can just watch them in a row. But we were in that house, and they had heat pumps installed, one upstairs, one downstairs. They already had forced hot air system for the rest of the house, and the owner was saying, yeah, they're kind of like three season, because it can't handle this house when it's minus 10 or minus 15 degrees. It just can't keep up. So we were interested, that as building scientists, we're interested in, it makes sense. How leaky is your house? And the house was, once again, 20 air changes per hour. It was, really, really. But in the basement, you could actually look outside. There's like areas like that you could see outside. The whole foundation in Barre is usually, from the house that age, is granite, leftover granite from the quarry down in Barre. So anyway, so they had these heat pumps, but the heat pumps were not going to keep that 1,800 square foot house in good condition in a cold period for a number of reasons, which we can get into. But I just want to get into now just what is a heating system. And we can talk about cooling as well. Some of these things do heating and cooling. So a heating system basically has three components. It's got a heating source. That's either your furnace, your boiler, your heat pump, or whatever. You have a heat distribution system. That's your radiators, your baseboard radiators, forced hot air, things of that sort. And then you have a control, which is almost always an on-off thermostat, although there are some systems where that is not the case. So once you can grasp and understand that those are three different bits, even though the control is really so simple, we usually don't even think about it as part of the heating system. We were in the house in Isle of Mott, where all of the thermostats were turned off, but the boiler was still on.
Yeah, exactly.
So you never know.
In summer, that's the thing.
That was horrible. Okay, so let me just go to the next one. Let me see. That's me, and then I'll turn that one off, and I'll turn the types of heaters. There we go. Okay, so here's the next slide. So the types of heaters that we have, and this is a pretty good list. We got furnaces. Furnaces are things that heat up hot air and then or heat up air and then distribute the air at very high rates, because air does not have a lot of energy density. It's hard to get a lot of heating energy into air and still have it not like burn a person, right? You want to keep this all safe. So the hot air that's blowing has to be pretty hot, but it also has to be a lot of it, so in order to carry the same amount of heat that water carries through from a boiler. So here you have furnaces, and then we have boilers. And boilers are pretty straightforward. They're just like furnaces. They can be run on natural gas or oil, or I haven't seen many furnaces that use wood or pellets, but there are certainly a lot of boilers that use wood and pellets. The Froiling, for instance. Then we have heat pumps. Heat pumps are super efficient, getting more efficient all the time. They are basically a refrigerator, right? Or a dehumidifier. You've got something called the Carnot cycle, and it takes a gas, and it turns that gas into a liquid at one part, and it lets it become a gas again at another. And at those two different places, you either get heat or you get cold, and it can capture that and distribute it. It often distributes that over a fan coil, which means you're getting air once again as your heating medium. And that's okay. It just that one of the things we know about heat pumps is that they have they need a lot of time to deal with really severe changes in the house. They're usually okay with temperatures outside the house, but once you're inside, let's say you've all heard of setbacks, right? Where you would turn your thermostat down at night. In a house with a heat pump, you're not doing yourself a favor because the house will cool up, and then the heat pump has to work really hard to get all of your surfaces back up to temperature. That works with something with a lot more, energy going through it, like forced hot air or a boiler. Okay, so let me just get back to that. Oops, I don't want to forget to finish the heaters. And then we have This is a government slide. I wouldn't put active solar heating. Nobody in Vermont, except for a couple of people who are really into that type of thing, are actually heating with active solar and electric heating. Funny enough, electric heating on its own is illegal in Vermont. You're not allowed to have baseboard electric as your main heating system. That was implemented, I believe, in the 1970s. But that came into conflict with the state rules, or the state pushing for people to go to heat pumps because heat pumps run off electricity. So when we were starting to make these better insulated and low energy houses and say, well, we want to only have a heat pump, and the banks are saying, no, we can't do that because if we take our loans after we get them from you and we try to sell them to Fannie Mae or Fannie Mac, they won't buy them because it's an all-electric system. So,
Chris, if I may, on that one question, I think that it bears the question is because people are going to be watching this and get concerned. Okay, because we've been in those homes where definitely electric baseboard heat that is historic is still in place.
Yeah.
And people are saying, well, what do I do about that? Some people have rendered it inoperative and replaced it with other heating systems, but for others, they still rely upon that in some of these rooms. So basically what you're saying by the regulations, if they go to sell their home, then they are no longer allowed to sell that if that's the primary heat source. Am I correct in what you're saying?
So you would have been correct if the state hadn't changed the ordinance about heat pumps specifically. So you're not allowed to use baseboard electric heat as your primary heating source, but you are allowed to use heat pumps as your primary energy source. There were a couple of years in the 2015, 2016, where people were when Fish and Mart was really starting to say, let's get those heat pumps in. And then the state was like, we've got to change these regulations. It's obvious that these houses that are heated just by heat pumps are just as resilient as houses that have a fuel, different fuel. So they changed those rules, and thankfully so. That was an important move. Okay, so let's move on to the distribution, which is what we'll be talking about in the interview later today with Jacob. So we already talked about some of these. One of them here is steam radiant. Obviously, this is by the Department of Energy. They need to also think about all those people living in places where steam heat is still a thing. I grew up for a lot of my life in New York City, and there was a lot of steam heat. The clanking of the steam heat pipes was always keeping me up at night. I'm a very light sleeper. So we have here forced hot air systems. You guys have already seen that. We have a radiant system. Forget the steam radiant because it's not something we see here in Vermont very much, but it is a radiator, right? It's a radiator standing in a room. You also have radiant heating, which is where you have radiant floors, but also, and what we'll be speaking about later today with Jacob, is radiant ceilings, which is very exciting in my opinion. Then we have what most Vermonters know and see if they don't have a forced hot air system, hot water baseboard heating, right? You have slant fin radiators going around your house, and sometimes when Jim and I are on an audit, and very much so on the Isle of Mott audit, if you want to watch the eavesdropping of that audit, that house had baseboard heat radiators along every square foot of exterior wall of that house. And that tells you how many BTUs that thing needs to keep it
Exactly.
warm. So I've built houses or been involved in building passive houses that could get along on 1 8-foot length of slant fin, and this house had what 100 feet of it.
Oh yeah, at least.
I mean, that was the double 275 gallon tank, right? They're just
Yes.
pumping energy out into the universe. And the last one they have here is electric baseboards, and I think this should be amended to include the air delivered by a heat pump, right? It's the one thing that isn't on here, like ducted heat pumps, for instance,
Sure.
are something that should be put on that list. And so the other thing that they had, which I thought was really good, is they also had a page on space heaters. And we see these a lot in Vermont, right? We see a wood stove. I have a wood stove. Jim has a wood stove. So none of our houses are completely one fuel or the other. I would say with my house, just because my house is so well insulated, and I have two heat pumps so I can distribute the two point source heat pumps so I can distribute the cooling and heating in a more controlled way. 99.99% of my heat comes from that. The wood stove is used because it's cozy, or it's used when there's a power outage and we can't run our heat pumps. And Jim, I think you said as well, you do almost primarily wood for your house.
Exactly. And it's rare, if ever, that we have to use our propane boiler, because the one we got one from Vermont, or excuse me, Woodstock Soapstone. We got one of their ideal heat units, and it won awards for the most efficient, most cost effective. Definitely recommend that. It's in Hanover, New Hampshire. Go on their website. You'll see really beautiful units, and also it's very, very efficient and cost effective. But we've had that for several years, and it does a stellar job. Of course, like Chris's house, mine is really well insulated, really well air sealed, and so it's able to do that. In fact, in the shoulder seasons, it's harder to control wood heat, so we find ourselves maybe cracking a window to alleviate some of that extra heat, because I don't like it that hot, but it works very effectively as a space heater. But then you could say that space is my whole house at the same time until it gets really, really cold and below zero, and then we need supplemental.
So another thing that's on this list that we see all the time are direct vent wall heaters. That's the Renai's most often, but we've seen there's like Eagle. There are like 4 or 5 brands out there,
Sure.
and then fireplaces. And Jim and I are very reluctant to call fireplaces heaters.
Yes.
I
Yeah,
mean,
because like what we said earlier, you get this fire in the middle of the house or in a room in the house, and it's great where you are. It adds great ambiance. I get it. Some people we've gone into their homes. We only run it at Christmas time because they want that ambiance. But other than that, it's a chimney in your house that's letting warm air out. And once it depressurizes the house, since it doesn't usually have outside combustion air coming into the firebox, usually it's just a normal fireplace,
no.
and then it's going to bring colder air to equalize the pressure in the house from other areas of the house that you don't want, and it makes those other rooms, outlying rooms, colder.
Yeah, and sometimes at a rate of 500 CFM or so. It's not
Yeah,
a
it's
little
pressure.
bit of air. I mean, it's like
Sure.
having all. It's like having 3 dryers running at once, just flowing air out of your house. And the radiant benefit that you get from a fireplace is almost negligible. Yes, the fireplace after a while gets warm and starts radiating in the house. But if you have a wood stove, I mean, the efficiency of a burn in an open fireplace is like 35-40%. But you get it into a decently made wood stove, and now you're talking 75%. And if you get one of these super well designed ones, like these Swiss ones, you're probably edging towards 80-85% with a good hard hardwood that's been kiln dried to 12% or 10% moisture content. So those are the things. Now I just want to chat a little with Jim about this week alone. We've had 2 conversations with 2 different clients about heat pumps, and
Yes.
in one of them. I thought that at the Barre house that the location of the heat pump pointing right over the stair for cooling isn't great, right?
No,
I would have put that heat pump in the bedroom, which is where the people
sure.
are going to need it.
Well, they were
Um,
using the fan to try to direct it into the bedroom from the stair, and with that very thing, you saw that there was an uncomfortability issue. And yes, it would have been better to have that head properly located.
So the location of if you're using single head heat pumps, you're going to have one outside compressor and one inside head, and those are great systems. They're actually probably the most efficient of the heat pump systems because the if you have multiple heads on one outside unit, the units sometimes don't run very optimally, as we found. Hopefully, they'll be able to work those out because it's a great idea to be able to cool in one room and heat in another, especially when you have, shoulder season weirdnesses going on in your house where a top room may be too hot because the sun's been hitting it, but a lower room is chilly because it's been out of the sun for a while. There are ducted heat pumps, and ducted heat pumps are great, but they're hard to do in an
Retrofit.
existing house, right?
Exactly.
You're going to have to do a lot of sheetrock work if you want to make that out, or build chases and things like that. So,
Sure.
and most importantly, and Jim and I will just say this again and again, if you're going to be doing heat pumps, make sure that you talk to someone like Jim and I first. Have us come out because you may put a heat pump in a house and it's just not suitable for it. Not that you can't do things to make your house suitable for it. And if that's something you want to do, then we're more than happy to help with that advice
Great.
as well.
Yep.
Go ahead,
Great,
Jim.
great example I have is one of the audits I did before you and I were doing audits together. Is that it was a home over in Jericho under near the post office turn, whatever, Old Pump Road, I think is what it's called. And we did it. It was a newer house. It was 2010 build, and with that, they this is when I had. It was actually a 2000 year 2000 build. Excuse me. We did the work in 2010, but we they had appointed the house with a traditional heat system, but their master bedroom, which was on the second floor, was inordinately uncomfortable. And whether it was winter or summer, and it was one of those times. And see, I came originally from warmer climates in Southern California and in Florida. And so, but when I came into Vermont, it was all about, hey, preserving heat inside the building and keeping the cold out. And so all this weatherization work that we were doing was trying to make the house more comfortable from that perspective. But then we did the work during the summer. And after we did the work during the summer, they actually had a mini split up in their master bedroom trying to cool it down. And after the work was nearly completed, the homeowner called me up and she says, I just have to tell you how stellar this work is, how it's fundamentally changed our house. And we can finally sleep in our master bedroom during the summer month. And I said, wait a second. Hey, this weatherization work works all year round. And it was, a little bit of an epiphany for me, but yet that's what Chris is saying and what we were saying. You have to make sure the house is right for the system you're installing. What you don't want to do, and we see this too often, if you have a really leaky building, put an oversized system in so that you don't have a cold or no heat call during the winter if you're the HVAC professional. You have to make sure it's properly sized for the building, but yet the building is properly appointed once again. And so if you have even a newly built structure and you're not addressing things appropriately, you're going to put this in, think it's going to solve the problem. It's not going to help the way you think it is. So you have to make sure you're looking at the building. That's why Chris says, not just having, it's a home performance review. Take a look at it. How do you make the house right? And what systems do you choose to go in thereafter?
Yeah. So Jim and I live in different houses. They've got different systems. We're constantly in people's houses where those people have got different systems. Usually in Vermont, we have this joke about this program that Optimizer, which was an attempt by
Here's it again.
attempt by the state to create a tool that would do a good job at modeling a house and its energy use based on just a couple of parameters. And when we were going into this, the company that made it, perfectly good company, trying their best, were usually not in the Northeast. And the Northeast is a particular place because we are the oldest housing stock in the country. And we have super, I would call them chimera houses, right? Houses that have 5 and 6 additions, 3 different basement, 4 different basement types, 5 different heating systems. And when we tell them to these people during these meetings, they're like, That can't exist. And we're in a room full of energy auditors, and we're all looking at each other. What kind of world are these people living in? I've been on
Sure.
3 audits this week, and they all did not have just one type of roof and I mean, they were like, we could add another one. And we're like, no, we need you to add a add button, and we can add as many as there are. And it just never did end up working. But that's what we have here in the Northeast, and Vermont is a perfect example of that. We did get a request from one of our clients this week to talk about replacement. They've got some equipment that's aging out, and they wanted to know our advice about equipment, and that equipment was a boiler or something to provide hot water,
Hmm.
which can be just about anything, and domestic hot water. So. They have a hydronic heating system. They also burn a lot of wood. But as they're aging in place, they may desire to do less physical work to keep their house warm
Exactly.
and do more not chopping wood and feeding the fireplace all day long. So they were asking about heat pumps, and we were saying, look, you can do heat pumps, not necessarily right now in your house as it is. Although we never got a blower door number on, so we should hear that. Blower door is a very good indicator of whether a house can hold the air enough to make a heat pump worthwhile. But there are also heat pumps that provide hot water. And so if you have a radiator system, you should be able to use a heat pump to create that hot water. However, heat pumps are not very good at making very hot water. Heat pump, a boiler is really good. A propane boiler or a natural gas boiler or even an oil or solid fuel boiler like we saw the other day, wood, coal, and natural and oil. Those things can get your water up to 170, 190 degree split that you want. 190 degrees to the room, 170 degrees back, heat it back up, and it's very good at getting that very hot. However, a radiant system or a heat pump, air to water heat pump or water heat pump, it really likes water in the 100 to 130 degree range. That is where its sweet spot is. And the way that we handle that is, if think about your radiator, your slant fin radiator in the house you grew up in or the house you're living in now, that baseboard radiator that goes around the rooms, right? Um, that has the way the equation works for heat transfer in anything, just like the heat exchanger in an ERV or an HRV. It's all about surface area and delta T, the change in temperature in the surface area. If you have a small area, you need to have a very high temperature going through that to get the BTUs out of that while it's going through the room. If you have a really big radiator, like say your floor, then you can lower the temperature of the water that's being serviced by that has to go through there to keep that room warm. And then you could move to something like the air to water heat pump, like something like the Sandon, which is a pretty well known one. But there are quite a few on the market now that work really well. So radiant floors are a good way to get heat out. Like usually in a radiant system, I don't know if you've ever seen it, but it's these tubes going back and forth, and they run about 12 inches apart. Oftentimes in concrete, but sometimes in a flooring system that's made out of a wood. And you have to be careful about not putting furniture on top of it or putting rugs on top of it, because that is insulative and slows down its ability to heat the house. But what I've been learning is, if you have a boiler, a propane boiler, and your boiler is a condensing boiler, unless you're running it for a low temperature radiant system like a radiant floor or one of these rentals or these other low temperature European radiators, which are much larger in size but can use much lower temperature water, you're not getting the benefit of the condensing part of that burn, right? The condensing boilers, when they're not condensing, are about the same as any natural gas boiler. They're like 85, 87% efficient. But when they're able to do water at a lower temperature, they can use the energy left in the gases from the first burn and condense the water out of it, allow them to do what's kind of a secondary burn, and that increases the efficiency up to like 94, 95%. That's a 10% difference. Over a year, that can make a pretty big difference. So large radiators that can use a low temperature fluid running through them are much more efficient. So the radiant sealing is something that I've been studying or had studied, like I said before, with Professor Robert Bean. He's one of the authors of the ASHRAE 55 standard. That is a comfort standard. Really interesting standard. I highly recommend it if you're into nerding out on this stuff, to get the ASHRAE 55 and find out about what a clo is. CLO. Clo is amount of clothing you had on. And in the 1970s and 60s, they had rooms full of Danish students wearing different levels of clothing and then asking people at different temperatures what their opinions were about their comfort. Interesting studies, and I highly recommend taking a look at them. Anyway, so what Robert Bean was saying about radiant systems is that radiant floors are only 60% radiant, right? The other 40% is convection, and convection is a type of heat that works. It's just not as efficient as radiant. I already talked about that. Air has a much lower energy density than a surface being hit by long wave radiation, the kind of IR radiation that type of system puts off. So how do we get that back? That 40% is, he says, put the radiators in the ceiling. The radiators in the ceiling have 100% radiative. Now I'm thinking in Dutch, uitstraling, there you go, radiation, because there's no air above it to heat up and start a convective path, right? That convection starts because there's all this air above the radiant floor. The air gets heated and starts rising, and that displaces colder air to go below, and it starts this convection. So this is the most efficient form of radiant that's around. Now there are downsides to it. Like, you got to make sure that you're not putting holes in your radiant system, otherwise you're going to puncture your radiant tubes. So you have to be careful about that. So you have to educate your clients about that. But I am a big fan and will be using radiant ceilings at 10 old stage. So stay tuned for that. We're going to, so just an update on 10 old and where we're going with that, since I went back there, is next week, when I can get him, when he's not doing the 7,000 things he does otherwise. Jim and I are going to install a window at 10 old stage. Yes. And we're going to do a complete videography of that, and have videos of that, and talk about the different types of windows we'll be installing and why we're doing what we're doing when we're doing the install. So that's going to be very exciting. Sure. I don't know, Jim. A lot of people get kind of queasy, especially builders and HVAC techs, when I start talking about putting fluid lines in the ceiling. What's your visceral reaction to that? What's your gut feeling?
Well, certainly you already have plumbing in the ceiling, and you've had leaks from that. You have tubs upstairs. You have leaks from that. It's just getting your head wrapped around it and where it becomes commonplace. And it's all about the installer as well. Is the installer making sure all the fittings are right, or are they kind of putting something on and they missed it and it's going to leak later? So it can be an issue because you do have a fluid in that space, but yet you're already living in most homes where you see that. Unless you're a single level ranch in our area, you better not have any plumbing in the ceiling, because it will crack and it will cause a problem. That being said, as long as you know where the pathway is, because I've been in situations where they have the old electric radiators in some of this older housing stock that was below
ceiling, right?
Yes.
That place in Jericho that we went to. Yeah, the woman who had she was wondering why her bills were so high, and she had her hot tub on all winter.
Yes, but you
nice woman. Yes,
so definitely.
Yeah.
But you put the infrared camera on there, and then you can see the pathway, and that's what's great about infrared, because if you have radiant in the slab, you can find out where those tubes are running, provided the heat's on, and you can miss those tubes.
Yeah.
When it comes to your ceiling, depending on how close if you're putting in contact with the substrate of the sheetrock, then you got to be careful about what you tend to hang in the ceiling, because you got to know where those tubes are. So you don't want that to happen either. But other than that, as long as it's installed appropriately, you know, you can design something. It's only as good as the actual application and how it's installed. That's what's going to make the design work.
Yeah. Yeah, well said. I did want to bring one more thing up before we go to our Old Stage Road update, and that is I got a bit of merch here from. Let me see if I can get this up. Here we go. I got some merch from Sega. Mark Coviello dropped off some tape a couple of weeks ago. I just wanted to say thank you for the T-shirt, Mark. And when I got my windows delivered the other day from White Windows, they gave me a T-shirt also. I was going to try to show that one, but for some reason I misplaced it. So we're going to now just jump into the Old Stage Road update, and we'll see you after the update. Hey, it's Chris West from House Calls Vermont. And I am here at 10 Old Stage for another 10 Old Stage Road Deep Energy Retrofit update. Boy, that's a mouthful. I still have the pleasure of having my son Sebastian, one of my children, here helping. And I was pointing out last week that we had a rotten beam in our post and beam. And so today was the day that we started actually excavating that. And we ended up finding, or Sebastian and Jack ended up finding, that there was quite a bit of rot in the beam that was the supporting beam. So here we have, you can see that beam there. That's had a chunk pulled out of it. That's the 8x8 beam. That's the original base support for the frame wall, right, the timber frame. So in the corner here, I had showed you in the last video, we had this beam, right, and that beam was going up, but it was rotten at the bottom. It was sitting on rotten wood. So here is the piece of rotten wood that used to be the bottom. So this was laying like this, and you can see what horrible condition it's in. It's just completely rotten. I can almost stick my fingers into that wood. Of course, it's been there for, 150 years or so, so it's not unusual, especially when it was in contact with the wet ground and probably dealing with quite a bit of moisture. So Sebastian and Jack, they worked together, and they put a supporting column right here on the inside of the wall to hold it up for structure while we're doing this. So when we pull that beam out, that beam and column, that the whole thing wouldn't collapse. That would be kind of a bad thing. And so this is the type of thing you see when you start pulling rotten wood out. It's obviously quite a lot of wood bits, and coming inside, you can see right over here, here's that supporting site-made support that Jack made, and over here we can get a better look at all of the things, as they say in modern society. So the beam used to be right here, and you can even see that they had to cut the mortar, the tenon out of the mortar and tenon in order to get that beam out. So that has been removed. We've created a weld here. So we're going to be bringing in a new piece of wood, and that new piece of wood is going to fill this space, and that will be welded here. So the other one will have the negative cut out of this, and then we'll bolt them together so that it acts as one piece.
Hey Dad, you'll like this. We were looking at, there was some concrete down by the rotted out bit of this beam, right, that was sitting on the floor. And we saw that some people that were retrofitting the house probably in the 1970s or 80s tried to fix the problem of the rotting wood by pouring concrete to accommodate for the lost wood, as if the rot wouldn't spread further.
So that's great. What a find, right? They poured concrete onto the wood in order to, support it. Of course, we know that the right way to do it is what we're doing, or there is an option where you dig out all of the rotten wood and you use an epoxy to fill that. But what what Sebastian found is not the supported way. So you see it here. They poured this piece against this piece of wood here. This is the supporting beam, and they poured this concrete in to try to fill the gaps and keep it standing. That was not a successful retrofit. Although we are 30 years later, so maybe it was partially successful. It lasted that long. So another thing that we're looking at here today is we have taken off the exterior siding on the north side of the building, and that's this. And I haven't done that up until now because I wanted to wait until we were ready. Now, we haven't taken it all off because power is still running along the bottom and over to that pole. I have been told by a couple of electricians who came to work on this that is one of the longest cable runs to a transformer that they've ever seen. Not a distinction I'd like to continue following, so we're going to get rid of that. One of the things that Sabah noticed when he was pulling this down is that they ran electrical wires between the siding and the so it was a vinyl siding and the paper that was the building wrap, and they did it around this kind of insulation they had. So let's think about this: 1970s and maybe early 1980s. They want to make the house more energy efficient, and so someone says, hey, what we need to do in order to do that is add some insulation to it. So it started out with probably 4 inches of dense pack rock wool between the studs. It's not really studs, but between the framing members of the inside of the timber frame, and then on the outside they put this wrap, and then they added, as you can see here, I'd say it would be generous to call that a 1/2 inch, but approximately a 1/2 inch, maybe even a 1/4 inch of a foil faced rigid insulation. So that little amount of insulation has an insulative value of about R1, because this insulation is R4 per inch and it looks like a 1/4 inch. We could say, if we wanted to be generous, that it's an R2, right? More importantly, this insulation board was put on the outside and was not taped for air sealing or fitted in a way that was going to be anyway beneficiary for air sealing around the gaps of it. And then, even worse, is that it is a foil-faced material, meaning that it's completely vapor closed. There's no way moisture is going to be able to dry through that material. And the gaps at the edges where these bits were connecting is certainly not enough to allow for a good amount of drying. That being said, when I first took the interior plaster and lath down, the insulation that was on this wall was wet to the touch. So it wasn't working the way they wanted to, because wet insulation has the same thermal conductivity as water. So we got this down. We will be building out. The idea here is the windows come out. We'll be pulling this window out and that window out. And we will be, I've bought some boneyard windows. Now, what are boneyard windows? Just real quickly, there are some window manufacturers, happens to, in this case to be Windows by Brunel down here in Williston, that have windows that they bought, that somebody bought, but nobody ever picked up. The order was wrong, usually, or something like that, and they call that the boneyard. And those windows are for sale at usually about 50% or more off of the original cost of it. The downsides are you get what's there. You get the size that's there, you get the type of window that's there. Fortunately, these are Marvin windows, so they're not really bad windows. They're just okay windows. They're not like the Wythe windows, which will be delivered on Saturday, that we'll be making a video for the next episode. So we're going to be building this assembly out. We're going to be putting I haven't decided if it's a TJI or a site-built Larson truss, but we're going to put an exterior insulation, get us up to R40, which is the high performance program, and fill that with cellulose. So it's going to be an R40. You're talking something on the order of 10, maybe 11 inches coming out from this wall, you know, like this. And then there'll be a window buck that will be sitting over there and supported by the outside wall, and that'll be the assembly. I'd love to do it with a rigid Gutex type material, but the Timber HP won't be ready in time for me to use it. So other fun stuff that happened this week is that we pulled off the front of the old porch. This porch was added years after the original building was built, and I know that because if we go inside here, I don't know if this window, this door is open. Let's see. Yes, it is. Okay, so and I need a bit of light on that for you to be able to see it. So let me grab my flashlight from my camera, and we'll look up here. So this house was built in 3 phases, maybe more, 4. The original brick part from the 1830s, the wood part, which we have already talked about, the summer kitchen, which is probably from the 1850s or 60s, and then this porch was added at some point in the years after that, and then the garage was added on the other side. But what we see here, right here, is the original gutter, and then on top of that we can see the original shakes. That's a cedar shake roof. So that's a wood roof, which would have been the original roof, with a hand-carved wooden a gutter, which I have a couple of. They're very cool. I'm planning on cutting some of those up into 1-inch bits and, you know, turning them into artwork and selling them to people, or giving them if people would be interested in that. So this building, this part of the building, which is the porch, was probably originally an open porch, or maybe it was always closed in. But you can see very clearly it had some nice work done. Here we have a nice grooved ceiling. We have some panels here, right? And then sometime later, this thing was added on top. So it originally had a lower panel. You can see that panel pretty well made. And then in the 1980s or 70s, or maybe even the 50s, someone built it up and added all these windows. I'm not even sure the original porch had windows. It might have just been an open porch for sitting on while people are riding by in their carriages, of course, because it's how people were riding by back then. We also got to look under. It seems as if the entire structure is built on a couple of metal poles that go into the ground. We haven't excavated those poles yet, but that seems to be the structure of the wall, this wall, right? That's furthest away from the house. And that's kind of weird. But the reason we originally did this, and we're still deciding whether we're going to keep the porch at all, was that I needed to get access to this corner. Once again, this is the brick part of the building, and we're going to be attaching this plywood to the building using bolts running through, and then we're going to be hanging 5 inches of insulation, 5.5 inches of polyiso off of this, and that'll fill up that gap there in the buck. And then we'll be doing double strapping, vertical strapping for a rain screen, horizontal strapping pardon me, to hold the shiplap we're going to be using for the exterior treatment room. But I do have to wrap the insulation around here onto the brick, and we will be doing that. So I needed to cut away at least 8 inches of this. Ooh, that looks like a pretty crazy rug. I hadn't seen that before. Pardon me. God damn, something in my throat. Because I want to wrap that insulation around there, right? So that's what's going on here at 10 Old Stage. Maybe I'll do the last bit again. And so this is the porch from the outside, and the whole porch, as we were pulling away the bottom material that was covering up the bottom, as you can see here, this has been recently exposed, are these metal poles. There's one there, there's one there, there's one a little further down. You can see them here. That's it. And that's pretty much what's holding up the entire structure of the wall, the outside wall, this wall of the porch. Obviously the other wall is an existing wall of the house. And the reason that we were doing this is we needed to open it up because over here we have the part of the building that is going, the brick part, see? And we're going to be affixing this plywood onto that. This is a 3/4 inch PT plywood, and we're going to be screwing into the plywood to hold on the polyiso insulation, and I need that to wrap around the corner. So there will also be plywood here, and then I needed this no longer to be have a wall there. You can see the deck. I mean, the porch used to go up to there. I told him I didn't want him to cut that away yet, just because I want the rain protection. But in the end, this ceiling will be, the roof will be cut back to allow for me to put insulation on all the exposed brick and get a nice warm blanket, continuous insulation around the entire thing. So that's what's going on here at 10 Old Stage, and we'll be doing a window install next time, so we certainly want to stay tuned for that. So here's that time lapse. I did a time lapse at the very end. I didn't have so I apologize for that time lapse being so short. I set the timing speed to once every 5 minutes. I should have done once every like 10 seconds. It would have been much better. But I did another one today when I was putting that plate up. I'll explain it next time. So that was the 10 Old Stage Road. Yeah, amazing that the entire outside of that deck of that porch is just these 4, you know, iron posts that, you know, they're hollow. It's just going to be a tube stuck in there. Who knows when? Not rotten out. It's still there. I was just telling Jim, I think the whole thing is really being held together by paint. You know, the great glue of everything. So now we're going to keep going. We're not going to have a big discussion. I just wanted to throw that. We're going to go to the energy audit. This is part 1 out of 4. Part 1 is the walk around. So
Yes.
I hope you enjoy. Good morning, it's Chris West from House Calls Vermont, and we are today in the town of Barre, and we're going to be looking at an old house. Looks like probably late 1800s, early 1900s. We'll find out from the homeowners, who are Stephanie and Joe, exactly what the date is. Let me just strap my various things on. I got my flashlight, got my distance meter right here, distance meter, so I'll take notes as well. So let's go on in and see what's going on. An audit usually starts, with leaving my battery in the Prius. We usually start outside. So Jim is inside talking with the owners. They have a cute little dog, Addie, who's a bit afraid of people. But we're going to be taking a look at the entire house, even though the main reason we were called was for basement.
Kind of show the foundation. Like we had a big water main break here and up the road last year, or was it earlier this year, I think.
When you say here, you set up the road. So at the house, it actually broke too.
No, it just came
So
into
water
the
main
house.
broke above.
You got it fixed.
And then, oh yeah.
Yeah.
And did
There
it
was
get into the
water.
basement?
Yes, it did.
Okay.
Okay.
And we found out there were some cracks. Didn't you take a video, Joe?
Yeah.
Yeah, we can show
It
you
was
the
just
video.
pouring right in. Like
It was
water.
pouring right in.
Nice
so-
water feature you didn't want.
Yeah, so we didn't realize the foundation wasn't that high, or they didn't, or the ground
Water.
wasn't as low to block all the water.
Sure.
But it's behind. What is that?
So we got negative slope.
Understood?
Yeah.
Yep.
What,
And Barry, I'm not surprised.
what is the design right there up against the house?
I don't know what you're talking about.
That little wooden
The lattice one?
the lattice work. Yeah, it comes through the lattice work and down the slope and into the basement. So I
Okay.
don't know if we would have to take the entire lattice.
Well, we'll take a look. We'll let you know once we
Um,
get our eyes on it what we think is the way
The
to
northern
stop
basements.
that.
What have they? Well, let me back.
Did the northern basements was here?
They're the ones who initiated the call. They're going to be doing some foaming,
Yep.
and some basement work. But what is their scope of work? That
What are they proposing?
Yes.
Yep. So they want to encapsulate the basement, right? So they'll spray foam the top 1/3 or whatever.
Yep.
Okay.
I don't know if they're going to go all the way down. They're going to rip everything out. They're going to throw down the poly on the floor.
Yeah, probably they're more higher end drainage matting instead of just regular poly. It's
Right,
more
right. Yeah,
robust.
it's like 15 mil or whatever.
Yeah.
Yeah.
So then they're going to slope everything toward the sump pump, right?
Yep.
Underneath that.
Yep.
And then they're going to put a new sump pump in.
Yep, triple safe. That's
Yeah.
great.
And then they're going to put a
Put the
dehumidifier down there, basically.
Oh, they're doing that too, standard dry.
Yeah.
Okay,
Put the
great.
gravel back on over the polyurethane.
No, I don't know.
Or,
If they do put gravel, please make sure they know this, but
Yeah.
just please ask for like a cobble type,
Yeah.
because if it's a sharp
Yeah,
stone,
it's gonna
it'll
poke through.
puncture.
Yeah, yeah.
I don't even know if I'd want that. You know,
Yeah.
they say like you can walk over it, but I'd rather just walk on the poly.
Well, and if you have socks on, you get a running head start.
Yeah,
You can just slide right across.
And then just throw some water on
Yeah,
it.
put a
And-
mattress up against the end of the.
And sometimes it's not a bad idea to consider a rat slab, right? If you're
Later,
actually
yeah.
going to be walking on
Like a
top of it.
2-inch.
It's
2-inch
a
slab.
rat slab is just a really thin coating of concrete on top of something, and that just gives you a nice surface to walk
We
on.
might have a little bit down there.
Oftentimes there are spots in these old
Yeah.
basements. When is the house from?
Like
1909.
Yeah,
something.
That's pretty close to what I was thinking.
Have you had it radon tested?
Yes.
Okay,
Yeah.
and
Yeah. It was
Under 3?
Yeah.
Good,
Yeah.
good.
good.
We had to do that when we
Just
first
with all the
built the
granite
house.
here and everything else, we were wondering about that. Okay, that's that. So they mentioned that there could be some holes around the perimeter.
Yeah,
Stephanie mentioned
in
that.
the basement.
And then, what about inside? Are there
Yeah.
concerns inside that you've had? You've lived here for 5 years now. So are there concerns you've noticed during the winter months, summer months? Is it inordinately hot at certain times, inordinately cold? Are there drafts certain places?
I mean, downstairs, obviously, with the basement and everything, stays pretty cool, right?
Yeah.
So in the summertime, it stays pretty cool. Upstairs always stays a lot hotter.
Yeah.
So obviously, heat rises and
Sure.
and whatnot.
Heat
but-
does not rise.
Or yeah, it goes from where it is to
Well,
where it isn't.
warm,
But warm air rises. Yeah, that's the.
It's just
Thank you. I can't not let that go. If someone's, so hot air rises because the space between the molecules is further, and it's bouncing more, and that makes it just more buoyant. But the heat goes from hot to cold. Yeah,
Right,
Yeah.
That's just how they teach you in kindergarten.
I know.
Eighth
I know.
And then start it young and then have to correct it later. So. Okay.
And we got those what are those called?
Yeah, we
Heat pumps.
Yeah.
Okay.
Mini splits? Okay.
Which is great for 3 seasons, but in the dead of winter, it's not that great.
Yeah, we got one downstairs and one upstairs.
Okay.
Are
Okay.
they Mitsubishi?
Yeah, I think so.
I believe
Were
so.
they the hyper heat?
No, I
have
don't
no
think
idea.
they're hyperheat.
They should not have. So hyperheat is just a type that can go down to really cold temperatures. So usually when they're installed.
Fujitsu.
Okay, Fujitsu. That's there are 3 companies that make heat pumps from Japan. They're all good. There's not one that we prefer over another, but they should be rated for minus 15, right? And what's when they shut off? Minus 18.
That's why I like the German one, higher heat pumps, because they go down to negative 30.
Those are.
They're newer. Yes, this recently came out. They're always fighting to jockey.
I know. I'm so scary.
Operating temperature, so, right. Okay.
It could get to negative 30 here.
Yeah.
Yeah. Especially so.
Well, let me show you a few things because
Yeah.
I didn't know about the flood. When I went to the garage, you'll smell it immediately. It's a smell of mildew, like
Yep.
towels that were left out too long being wet.
Right.
And then you look up into the ceiling, and there's fiberglass over one of the floor systems where class 3 installation, exposed craft paper
right.
face, and also it's just there's some challenges there. So we can take a look at it.
Sure. And do a walk around.
Yes, do a walk
Yeah,
around.
yeah,
So we do like you guys to be engaged in this whole process. So please walk with us, and even when we start doing the infrared, that'll be really telling.
Yeah, that'd be cool.
Yeah.
To check for vermiculite,
Do we
of
get to
course.
wear
Yes.
goggles?
You can wear. Do you,
want,
do you
you can-
have goggles?
We do not prohibit.
But we don't provide goggles. I'm sorry. That's extra. Right?
It's okay, I do.
Yeah.
Me too.
Is she a rescue?
Yes, she was in her mother doggy were in Alabama at a euthanization place,
Oh my.
but her mom was pregnant with a litter, and same with her aunt doggy. They both had litters at the same time, and they just
Yeah.
couldn't have all the
So what ends
puppies
up
because there was like
happening, too, is-
24.
Yeah.
So they brought them to rescue.
Oh my goodness.
Online rescue.
Yes.
The roof pitches right
Right up against it.
right up against.
Oh yeah, that's strong.
It is.
Yeah. And we
Oops,
asked
sorry,
our
no, you're
neighbor
good.
to try to get gutters, but he hasn't really done that
We've
yet.
kind of done somewhat of a French drain out there a little bit, but
Okay.
but,
Yeah.
Okay. If you want to make a recommendation to him to call Claude at Verdun's gutters, they're the most reasonable and really effective. I use them all the time on my new builds.
Yeah.
And it's just because they're like sometimes not half the price, but probably 30 to 40% of the price of others.
Mhm.
Even right now, this hyperinflated market, their price is still staying consistent.
Oh,
so,
good.
yeah, they're really good.
And what was it?
Verdun's,
Verdun's.
Verdons. Who was also a famous golfer back in the day.
I was gonna say-
Was he a
Long
golfer,
time. That
or
sounds
is just
familiar.
the same name as a
No,
golfer?
no, he was not the name. The
Okay.
name was one that won one of the, I don't know if the Masters or one of the Opens, but anyway, he was very famous back in the day.
I'm
There's
a
I'll
actually-
tell you he's a golfer.
I'm a golfer.
Oh, really?
Oh,
I think
okay.
it was it Bagger Vance, that movie, or one of those movies that they came out with? Maybe it was the one that Verdon was in there. His
Yeah.
character was in
Yeah,
there.
yeah. It was
It-
Walter Hagen and Bobby Jones was in the back of it.
So my question is, what's going on under here? This is slab under us, or is this
I bet it's a
basement?
void in there. Where
Yeah,
mice
and then
live.
dirt.
Yeah.
Where am I?
But I'm not standing over a full height basement.
No.
Right,
no.
that's
None
the
of this
question.
is over the basement.
Okay.
No. This
Okay.
was definitely added on,
Added on.
probably in the 40s or something.
Yeah, it's all rough sawn. I'd say a little earlier, but yeah, I see what you mean. Okay,
Said all the knob and tube has been abandoned.
good.
Well, by the time we bought the house, we didn't realize our car wouldn't fit in here. So
We kind of were like excited to get, you know,
A garage, and it wouldn't
but
get
then we were like,
ruined.
no, I don't think so. I don't think we want to park the car here.
Okay.
Okay, let's take a.
One support, Chris. Here, did you see that?
Yeah, I'm seeing that.
All right.
Let's head outside and take a walk around. I did notice some gable end vents.
Okay.
A flat roof, one of those like.
Oh yeah, flat roof.
Yeah. Is it EPDM? What do you have up there on the?
Yeah, what is it? Rubber membrane.
Yeah, EPDM. Yep.
Just watch out for dog food.
Yep.
Landmine.
Usually if you stay close to the house.
Oh, you're better off.
Yeah, just careful of the little dog bombs bopping around.
So you got window wells around your windows. That's good.
Yeah, it's right down here that there's the little crack
Right.
that I noticed once the flood started.
Yep. And we'll want to take as much. Oh, yeah. Well,
Yeah, careful the little.
we're good. So no soffit vents. It's all gable vented. The gable start. There's one here, and there's one on the front of the house.
He said it's roughly 1,800 square feet. I would have thought it was bigger.
It looks bigger from the outside.
Yeah, it
That's
does.
Because
The height.
there's a. Yeah, inside. I mean, obviously the ceilings are kind of high, but also there's a big pocket right at the top
Yeah.
for the crawl space up there.
And
You
then
can almost stand up in it.
when the house got renovated, he added this entire porch.
Okay.
So the porch wasn't there.
Question.
Oh, interesting.
Do you
Yeah,
find
the porch was there. It was just a shitty one.
Do you find the house to be inordinately dusty at times, especially on the street side?
It seems like it, yeah.
Okay, because I'm just wondering. I'm seeing the ghosting up here,
Yeah.
and also that vent's pretty occluded.
Very dark, very dirty.
So that's
Yep.
just surprising to see a little bit there. So sometimes that is just.
This is our first time having a dog. We just need the dog
Oh, of course.
that
Yeah, we have to vacuum at least.
if that counts.
Okay, here's the unpleasant trivia question. What is 70% of dust? Yes.
Skin cells.
Skin cells.
Uh,
So we're all cannibals in one way or another.
Can you do me a favor and just feel under the siding there to see what we're doing?
What, did I lose the coin toss?
No, I'm just recording.
Just kidding. I think there's other siding. That's pretty
Exciting. That feels like an OSB or something, or
cool. No, I mean, that feels like
Plywood.
the paint right there. I mean, it just feels like paint itself.
Yeah.
I think they just sided over the existing siding like we normally see.
yep. With
Oh, look at that. They're getting reflection from something. See the corner there? The melting siding? The deformed siding?
yeah, I get that right here.
Yeah.
Oh, yeah.
That's basically the sun gets too hot and it could be a reflection from one of the windows at a certain time of day.
Yeah.
And it causes that.
Oh.
That's cool.
Unless
Classic
Cool that you can
Barre.
spot that,
And then
yeah.
you're-
Classic Barre leftover quarried marble or granite at the very bottom. I mean, that's classic here. I see it all over this area.
Yeah, but to get that done today, that's
Yeah,
so expensive.
that would be really expensive.
Well, I think the name was
So there's a
Granite City, pretty
Yes,
much.
yes.
yeah, there is. So that's the room we were just in. There's the garage,
Yep.
and so that's the conditioned space above
was
that
extreme
you
force.
were. Yeah,
My concern is the durability of that sill and what it's doing with water going back in, if it's pitched appropriately.
yeah, that piece between the garage and whatever they.
And this is all
Built
garage
up.
underneath here. So that when we saw that insulation,
That was the floor of that,
was
yeah.
that. So
That's what they did.
Okay, so that was up there previously. Okay, I understand.
No, well, when we had that room finished for
Yeah.
our business, we that's what the guys that I guess they wanted to insulate the floor or something. So.
Do you find that to be a pretty full floor when you're in there during the winter?
I'm
carpet
not
on
sure
it, so.
because I usually use heat in there.
Okay.
I'm a massage therapist.
Okay.
So I'll do massage in there. So I always have generally the heat on in the winter or
Gotcha.
heating bed.
Electric?
Heated bed.
Electric heat?
Yes.
Mhm.
Okay.
Yeah, baseboard in.
The mini split?
Yeah, just a mini.
Okay. And should this vent is for the dryer, I assume?
Nope.
It's not.
Actually, the dryer vents into the basement.
Yay!
Or not into the basement, into the garage.
Into the garage, right? Yeah.
That could be what we're smelling in.
Yeah.
That's
Your
what it is.
extra load. Yep.
That makes sense.
Yeah. Yeah, because in that there's so much moisture. And the worst
Yeah.
thing is, I fell for it before I knew better about building science. My first move here 25 years ago is I bought one of those because we were on electric heat. It was very expensive in a condo. I bought one of those little vents that, hey, you can recapture the heat.
Yeah.
We had so much humidity inside of our house. That's what you're having inside here, I believe.
I mean, if your house is really dry
Yeah.
in the winter,
So yeah, when they remodeled the house, I believe there wasn't even a vent in the laundry room. So we
Yeah.
ended up having to call him and be like, where's the vent go?
Yeah.
You know, and he was like, well, I guess he can put. He came back and punched a hole through the wall and then vented it in here. But
which is wrong.
yeah.
But that's okay.
So we'll talk
So
about getting that out.
what's that vent?
Yes, you got a vent here. You got a vent here.
Vent
I
here,
wonder what all
vent
these are
here.
for.
This is probably old, right? This
Yeah,
is
probably
before the
disused.
remodel.
anything.
That was probably, and then I have no idea. I've never even seen that.
We'll have to take a look back. I think we can see it from inside the garage. We'll just see it when we go back.
Maybe it's meant to vent the
It's
garage
plugged?
after
Yeah.
With
it goes.
fiber.
Oh, okay, someone closed it up on purpose.
Yeah.
Okay.
Probably when he did, because that would be where the washer and dryer is inside
so-
the house. So
Probably be
because
best.
he opened that hole, maybe he plugged that one. Or
Yeah,
no.
possible. This condensate line you have running underneath the line set is something else. Though this is the condensate line for the heat pump.
Yep. Yep.
This
That one's
for the
bigger.
boiler.
Oh, it's sump pump.
Okay. Interesting.
And is that going to be used? Are they going to repurpose? Are they going to replace that and
Move it somewhere else.
Or are they
I
using
think
the same
so.
one?
I mean, they were talking about directing it kind of out front. I think.
Yeah.
And then putting one of those units in. Or,
Yeah. The triple safe.
One quick thing about Ivy,
I can-
she tends to get around.
Yeah, I was gonna say.
And I have seen it actually grow underneath the vinyl, and then it becomes a moisture sponge.
Yeah.
Vinyl is already inherently bad for that. It holds moisture against the wall.
Right.
That would exacerbate it. I know it looks great, not great on vinyl.
To be honest with you, it got out of control.
Yeah.
It does that.
Yeah.
It wasn't that bad.
I was just noticing that too. I was just like, wow.
I mean, it
this
looks
is actually
great.
going.
Yeah,
like,
it looks great.
Yeah, but nobody looks back here. That's the
Okay.
neighbor's view, so I don't care.
Okay.
We had great house.
Yeah, but then you know what it does? It tears the brick apart. Does it? It does. They grow little feet. They grow little feet.
They have enzymes that eats away.
Brick house that has a lot of ivy on it.
But it's pretty. It looks great.
Working hardcore when the basement was flooding. I was like,
Yeah.
I don't even know really how much.
Yeah, I know, right? I
But
don't know how
whatever
we
you
got all the water out.
do your thing.
Yeah.
Save our basement.
So a few pieces I see, like the vinyl up there, the fascia trim. Yeah, it's come away by about 3-4 inches.
And the
Yeah.
corner,
Yeah, the corner. Then I see up here the socket's loosened up, and that's just normal expansion and contraction. But it looks like the piece is actually falling down, or they didn't do it complete. Look at that, Chris.
Yeah, I know. There's that one piece
One of
is
the
not the
pieces fell down,
same.
actually.
That's what it is. Then.
Yeah.
Yeah.
Okay. And that becomes a durability issue.
Because water can get in there.
And you can see the tannins, the tea staining. Yep. That's because it's hitting raw wood.
Yep.
Oh, okay.
And so yeah, I would definitely get that touched up.
Yep. Yeah.
That we'll put that in the report as
Doesn't
well.
matter how efficient your inside is, if the shell is not sound, you're gonna have problems.
Yeah, absolutely. Okay, let's go see your basement.
A vinyl siding installer to do it.
Okay.
But I hope you find one. Tell them it's a good filler job. Market it as a filler job.
Okay, so what city is this? It looks like Italy.
Yes, we were in, yeah, that's Italy.
Yeah, that's Florence.
Florence, I was gonna say.
We were in Florence for our honeymoon.
Oh, congratulations! I love
I
Florence.
took a bunch of pictures.
I got Disney World.
And that's one of the pictures I took when
Nice.
we were there.
Florence is awesome.
Went on a nice dinner cruise.
Moms.
Yeah, I'm doing it. Okay.
Italy and Paris.
Oh,
Nice. Hi, puppy. So now I can see where that. That. What the heck?
Write us a report, right?
oh gosh, yes. It's exhaustive. You'll have it in.
So what is? So they. I think that is your dryer.
Possible current market.
No, I don't know what that is.
And
I think
also
that's
all the details.
We should be able to see it from inside. Why don't we? What's on the other side of this wall?
the dry. I mean, that's
I
the.
think we might.
So that looks to me.
Yeah,
And by the way,
Oh, that's the
Building
vent
inspector report. This goes
for
way beyond.
the fan. That's what that
for
is.
the fan.
Yeah, the fan in the bathroom, probably.
Oh, that's possible. That's possible. It is.
gotta be what
It is angled at the right angle. It is smooth bore.
Oh, so there's a bathroom right over there?
Yeah.
Yes,
Oh,
it's
okay.
1.5 bathrooms.
That makes sense.
Okay. Let's take a look at that. But
We'll go to the basement first, Chris.
yes, please. Hi. So that was the audit. Nice couple. Interesting house. Ended up, and we'll see that during the blower door test, being quite leaky. The next episode is going to be the basement. The basement down there is pretty interesting. It has an old canning room. Sometimes in the old houses you find the most interesting stuff. So now on to the interview with Deva Racusin. We will be posting these interviews separately, so if you don't want to watch the entire episode or wait for the entire episode, please feel free to check in. And without further ado, here is part 2 of my interview with Jacob, even though I say at the beginning it's part 3 because it's the third part that we did. I'm using the first part for next week. So enjoy, and I'll see you after it's over. Hi, this is Chris West for House Calls Vermont. It is part 3 of my interview with Deva Racusin from New Frameworks. We're going to be talking. Welcome, Jacob, once again. We're going to be an odd thing happened. I think it was something like 4 or 5 years ago at this point. Give me just a second. My tape fell. Dude, you can't see behind the curtain.
Oh, adhesive failure.
Maybe I choose this to not be on that particular. Let's go to the techniques page. There we go. Something like that. I'll just leave that up in the background. More New Framework stuff. Okay.
Love it.
Good. Let me start that again.
Sure thing.
All right, we'll go. Hi, this is Chris West from House Calls Vermont, and this is part 3 of my in-depth interview with Deva Racusin from New Frameworks. Welcome back, Jacob.
Hey, Chris.
Hey, so we started talking about the culture of New Frameworks. We then went on and spoke a little bit about embodied energy and equivalent carbon dioxide, cradle to gate, and tools, and how we're trying to push these things on a policy level. But a number of years ago, you and I independently took this class by Robert Bean called Integrated heating design, which was given through HeatSpring, which I highly recommend. It's a great platform if you're interested in some interesting courses, and a lot of good building science courses on there. But this was a course specifically about using low temperature and sometimes extremely low temperature heating systems. And one of the things that was a hard one for me to wrap my head around during the course was the idea of, oops, I'm just going to leave the wires. What is the idea of exergy destruction? So when you have a boiler, and that boiler is running on a regular, say, slant fin baseboard radiator, you're putting 190 degree temperature water into the system, you're getting 170 degree temperature water out after it's heated things, and then that boiler is heating that 20 degrees up and again. And exergy is what we used to call, because it's a term that I was not taught in engineering school, used to be called useful energy. It's the energy you can actually use for the purpose it was created for. And what Robert Bean was pointing out, and Robert Bean is an incredible, interesting person in and of himself, and one of the co-authors of the ASHRAE 55 standard. He was saying that the higher the temperatures are, the more exergy destruction you're suffering from. The harder it is to get that useful heat or energy to the place that you want to use it. So the lower we can get those temperatures, the less we're destroying or we're creating energy that we can't use for its purpose. And we all know this. We've all been in a boiler room where the boiler room is 15 degrees hotter than the rest of the house. Well, that 15 degrees is the energy that system is not getting to the radiator, right? So, and efficiencies, right? If we're gonna burn a material, to turn that material into heat and have that heat transfer, what's the efficiency of the burning of the heat exchanger in the burner? All of those things lead to the general destruction of useful energy that we're spending resources to mine or to make the fuel, or to bring in the fuel from some other place. And part of trying to reduce our use of fuels is to look at that side. So when we have a heating system is a thing that makes the heat, and then there's the thing that distributes the heat. And the thing that makes the heat is the boiler, and the thing that distributes the heat is your distribution system. If it's forced hot air, those are your forced hot air ducts. If it's a radiant hydronic system, like a slant fin baseboard radiator, then that is the tube with the fins on it. And those two things are separable, and the efficiencies of those two things are linked to each other, but they're not specifically. The efficiency of the radiator system is not the same as the efficiency of the boiler, say, for instance. And in this class we were taught that if you can get your temperatures down below 130 degrees, that you are now dealing with a temperature that a condensing boiler can actually get its higher efficiencies, because it's able to reuse some of the fuel, some of the energy in that fuel, and get from the upper 80s up into the upper 90s. You can never get above 100% efficiency with a combustion process, because you have a finite amount of energy in each molecule, and that can only give up so much energy. When we're talking about heat pumps, it's not really that heat pumps are more than 100% efficient. It's just that it's getting the heat from outside of the system, and that is how we then can say that a heat pump is more than 100% efficient. And we can get into the details about that at some point in a educational video. But just for a point for this discussion, what we're looking at is super low temperature radiator systems. Radiant floor is the one that most people know about. There are also radiant pillars, also called chillers, and there's radiant walls and radiant ceilings. And specifically what Robert Bean was pushing was the concept of radiant ceilings. And Jacob is the first person that I know who has actually put together and installed a radiant ceiling system, which is what I wanted to speak to him about during this segment. So, Jacob, welcome back. Sorry for the long exposition to get started, but
that was great.
Set the stage.
Yeah, totally.
So, tell me about the is it just one project at this point that you've used that system with, or have you used that system in more than one project?
For the radiant distribution, yeah, just one project we did is new construction. Although I will say we did a weatherization job 6 some odd years ago, sometime in the middle of the 2010s, that had the complaint that we heard was that the heating system is really uneven, and in many cases just not sufficient. The homeowner couldn't identify any baseboards, couldn't identify any distribution they were building. We went up into the attic to prepare to do some just like inspection around air sealing. You're always digging around the attic floor to see where the holes are in the ceiling.
The distribution pipes?
Huge network of copper radiant ceiling distribution pipes with like this much insulation over the top, if any, and these massive holes where things are kind of like popping back down. And so we kind of made sure the system was good to go and, you know, pressure tested and leak checked and all that jazz. Made sure its operation was sound. Then air sealed and insulated the hell out of it. And then amazing. Her house is like, she loves it. Her heating system is just like absolutely fantastic.
So she was literally heating her attic.
More of it was going up than going down, which sure, that makes sense. So it's my second radiant ceiling project, but the first one that I actually did all the hydronic design. And we did it's a full design build in house. Yeah. And it's awesome.
So
it's so great.
Bring me through a little bit. So what I've been looking at is as a proponent of radiant ceilings. One of the things that we were taught by Robert in the class was that radiant floors are 60% radiant and 40% convective, right? There's a convective component to a radiant floor. You're heating up air, warm air rises, that pushes cold air, that cold air goes down, and you get these convective cycles, which there's nothing wrong with having a convective component to your heating system. It's just harder to regulate what's going on as soon as you start letting these convective pathways. We say that about wall cavities, right? We don't want, you know, voids in walls where moist air can circulate. There's another place we talk about convective loops. We talk about the stack effect. And how the stack effect affects how buildings operate, and that of course is a convective loop that's outside of the building, right? The air goes up and pushes out and then re-infiltrates at the bottom of the building, so that's a convective loop. But we try to keep convection down unless we're heating with convection, like forced hot air or heat pumps, because it's not as useful for transferring energy. Air is just much less dense as far as its ability to transfer energy than radiation. Radiation is much better. A surface that's radiating heat is better at creating and now I'm thinking in Dutch, egal, a level type of heat, right? Instead of a cool pocket here, a warm pocket there. When I'm doing my research to try to find products for radiant walls or radiant floors, I've been having to put stuff together myself, and you seem to have found a product that was kind of off the shelf. I want to hear a little more about this product, and you know, we're going to get a bit technical here, people, so don't get worried. We're going to talk about thickness. We're going to talk about the diameters of PEX and all that type of stuff. So get ready, strap in. Tell me a little about the BTU per square foot output of the system that you ended up designing, and the products that you were able to find to do it, and how happy you were to work with them.
Yeah, absolutely. So we ended up, I guess the quick caveat I want to give in describing the system, so as I know folks are immediately going to try to start applying it to their own project. So all this is predilected on a high performance enclosure.
Right.
And so just to be
low
like, super clear,
yeah,
exactly. Like that's how all this works. I'll say first and foremost, invest in your enclosure all the time, every time you unlock all of these mechanical solutions and these improved parameters around performance and impact and comfort when you're starting from a good quality enclosure. So just feel like I have to say that first.
Thank you for that.
So,
caveat is very important. When we go into a house and the first thing I'm doing an energy audit and the first thing the client says is, oh, I heard heat pumps were good. And I'm like, yeah, but your house is 20 air changes per hour at 50 pascals. A heat pump's not going to help you reduce the load, and then these other systems really work well. Thank you for pointing that out. Yes.
Exactly. Yeah, and so we actually initially were looking at radiant floor, and we've done a number of hydronic floor systems. And I try to say actually hydronic floor rather than radiant floor for the thing
because there's
electric just brought up. It's actually not. Yeah, there's conductive, and there's other things going on there too. So hydronic speaks of tubing in the floor. What we found in a bunch of these projects is that the whole idea of the hydronic floors being warm and the whole warm floor thing doesn't really play out for us because we're intentionally trying to keep those flue temperatures as low as possible for the sake of the performance and energy efficiency of the building. And also, from a control standpoint, when we only need these like little injections of heat in a low load building, if you have that floor warm enough that it is higher than the surface temperature of your feet by enough of a span that you can really feel that it's warm, then you're going to bake yourself out of your house. Yeah. And so we just haven't. It's been like a happy outcome. I consider it happy that. You don't have to have really warm floors. You just don't need that much heat in the building to be able to keep the building really even. So the forms don't feel cold; they just feel neutral. And so, that benefit isn't necessarily there from a radiant floor in a low load building.
And what Robert was teaching us is that studies have shown that there's a real low temperature upper limit to what's comfortable for people's feet. It's like 82 degrees is comfortable, and you get up to like 85, and people are like, my feet hurt. So there's also
you start getting sweaty. Yeah, totally, exactly. And you look at all the different factors of human comfort. There's like a dozen, maybe. There's about 7 that I can think of that I work with a lot, and asymmetry is one where heat's coming in different sides, and stratification is another. Like how warm is your head versus your feet? Like all these things really factor in.
Yeah, I call that the fire, the fire pit thing. It's 25 degrees.
Yeah.
And outside, the front of you is really warm. The back of you is really cold.
And you rotate like a stick. Yeah, exactly. Yeah, or like the rocking chair for the wood stove, or the drafts are blowing behind you. Exactly. And so in this project, we're initially looking at radiant floors. There's a couple of reasons that we moved away from them. One, a diversity of flooring types made the hydronic design a little bit tricky in terms of allowable fluid temperatures over different flooring types and some of those transitions. Another was furniture placement, and it was highly variable as to how much furniture was going to go where and how much of the floor aperture is actually going to be visible to us.
Yeah, and that is so dependent on the person, right? Because you could sell the house and they've changed their furniture.
And it will change.
Yeah.
So unless you're going to put tubing literally everywhere, and then that's a solution that can get pretty expensive. In this case, that was going to definitely be a cost driver, partially because of the product that we're looking at and working with, and partially because that would have meant we had to insulate the entire floor below. And so now we're dramatically increasing, a whole bunch of insulation that otherwise wouldn't have necessarily needed to be in there between floors. And so, a bunch of those things were all sort of conspiring together. They're like, well, let's look at the ceilings. And that ended up being like a way more targeted use of area, more predictable in terms of furniture arrangement, surface material. We are able to take an entire floor diaphragm of insulation out of the work scope. And then we had the advantage of everything in the room can be seen radiantly by that ceiling. It's all line of sight. Right. So all the belongings and surfaces in that room are up to whatever that radiant design temperature is. And so its effectiveness around creating this totally even, comfortable distribution of heat is really, really high.
And that also plays back to what Robert was saying, is that radiant ceilings are 100% radiant. There's no convective component because there's nothing above it to heat. The air is already at its highest point in the room.
Exactly. And so what we did in our project we had a couple of different conditions. There was like a great room that has it's like 2 stories plus a bit, so we call it 20 some 25 feet maybe ish from the very peak down to the first floor. And so those ceilings are all radiant. And then we had 2 stories that have more flat ceiling, kind of standard 8-foot tall ceilings. Those had radiant. And then the basement level, as a cost reduction approach, we use like a baseboard wall panels. So not a convective baseboard slant fin style, like fin tube style, but more actual like radiant panel.
Was that like a low temperature European type?
Yep. Yeah, Meissen and Runtal are the 2 manufacturers that I'm aware of. In this case, we worked with Runtal. Meissen is another direct competitor, kind of a Ford Chevy thing is my impression. So the basement was satisfied with those. About half the basement is unfinished.
Wait a second, did you just indicate that Ford and Chevy are not comparable? Your metaphors sometimes bring me places. Anyway, go on.
2 closely competing brands within the marketplace.
Basically the same product, yes.
I don't need to piss off any Ford or Chevy owners in suggesting there might be equivalence between those brands. Nor Runtal or Meissen diehards that have.
And they're out there.
I don't know enough about that world to comment any further, other than they're both good options. Yeah. But so we used our system. So first of all, there needs to be a generous amount of insulation on the non-heating side of those panels, because radiation will go in any direction along a concentration gradient. So if you want it to go in one direction, you need to make sure that it's a lot easier for the energy to go that way than the other way, which means insulation. The general term I hear thrown around there is R19. What I try to dial that in a little more specifically and look at a 30-to-1 ratio, that for every inch of R that is between the tubing and the room, try to get about 30 times that on the other side. And again, that's just a matter of efficiency, making sure that the heat energy is going in the direction you want and isn't warming up a cavity.
Right. If
that's not necessary. Again, it's a usefulness of that energy and efficacy of how that energy is being delivered. And so the nice thing about ceilings, and we already have in that cathedral great room, like the insulation is already there, so there's nothing extra. Yeah. The second story going up by the ceiling, like it's already insulated. We're already there.
Floor ceiling. That's the interesting one.
Yep. So we added insulation in that part of the room, and what we did, because our building was so low load, even with, I think our design temperature for the fluid was 110 degree entering water temperature. So the tank is 110. We actually had the tank set to 103 all last winter. And this is in Charlotte, Vermont. And we had some pretty darn cold parts that winter, and 103 was fine. Awesome. So we're circulating 103 degree water as it's entering the system, and that's keeping the whole house up to temperature. And so even with those low temperatures, we did not need the entire surface area of the room to be tubed. That was way more surface area than was actually necessary. And so we had some routing of that tubing. Actually, I routed around the perimeter of the building to really make sure that the cold surfaces of the walls and windows were going to really make sure that those were going to most directly benefit. And we were able to target our insulation accordingly. We didn't have to insulate every single bay of that floor. We sort of really insulated over where the panels were, and that was really targeted and effective for us. Whereas with the floor, we really would have had to insulate the entire floor for all practical purposes, not knowing where that bed was going to be, and we lost upwards of 50% of the floor area in any given room between closets, beds, dressers, and other furniture that would have really impacted the delivery efficacy of the heating system. So we were able to cut we cut like 30% material out of the installation in area reduction by going to ceilings rather than floors. And so should I describe the system?
Yeah, please. That was my next question.
Yeah.
What is the actual system?
So we have these insulated cavities. That's sort of where we just left off. We used a product called Warm Board. WARMBOARD. that is essentially like an MDF or an OSB or an MDF. Can't exactly remember. I believe it's more MDF style board that's routed to receive half-inch tubing. And it's sort of routed. They've got like, left and right turn ends, center turn ends, and then common middles. So you have some, a kit of parts that you then, they do the design to your layout to make sure that you have the right sets of parts that all map together. And it's routed to receive your tubing on, I think it's 4-inch spacing. So you have some, it's either 4 or 6 inch. So you have some play in what you want your tubing spacing to be, depending on your design needs. And then all of that is covered with an aluminum, it's like a heat
spreading plate
covering. It's spreading plate. Thank you. Exactly. So those just screw in or nail, but we screw installed those directly over the ceiling joists. There's some particularities to the install, but they've got a great system. It's really quite straightforward. And then snap in your tubing and cover that over with drywall. And obviously the big issue there is if you're installing anything over any tubing ever, making sure you're not hitting the tubes with your fasteners is the big thing. And so some particulars there as well, but that was relatively straightforward to manage and design.
I was just thinking, I've done a lot of audits where I've seen radiant floors with the IR camera. Were you running warm water through and using an IR camera to decide where your screws were going?
That's a great question. We had layout marks on the drywall. Really helped in the places where that really mattered, and there was just good oversight and coordination with the drywall sub. So our crew installed the warm board. We had our drywall sub install the drywall, and it was just a well-coordinated effort. And we had our heating contractor install the tubing. And so we were able to spread this work over multiple subcontractors and effectively manage that without any incident. We were really thorough in quality control, and it's, again, like good planning, good communication, and good quality control, and you're good to go. But that is additional. It's definitely an additional complexity, and would certainly would not shy away from that as being like a real thing to manage, especially if you're not doing the work yourself,
right?
And are subbing that out. You just need to know there's a liability and it needs to get managed well there. Mm-hmm.
So,
but our experience. Oh, sorry,
go ahead. The question that comes to my mind next is comparable costs to another system.
Yeah, that's where I was going to go next. The warm board itself is not cheap, for sure. That was an expensive product. It saved a lot of install, and we actually were going back and forth as to whether we're going to do something ourselves, work with that product, see if there's something else that made more sense. It ended up working for us, particularly because we were installing that overhead, on a slope ceiling going 20 feet up. Like, all right, we're going to go for ease of installation on this one because that, the labor costs can get really high. This project was complicated, so I don't really feel like there were so many various factors. Complexity of the shell. There's an interior timber frame. There's multiple different zones in the system, so it's a little hard for me to have some direct comparison to something else. Definitely more expensive than throwing up your garden variety baseboard. Partially because of the cost of the warm board in our case. Not that that's the only solution. I've seen quite a number of more sort of do-it-yourself approaches or custom site build approaches. John Siegenthaler actually has some great examples of some radiant ceilings he's done. That's just layering up some polyiso board and putting up a grid to get your tubing to clip onto. And you can totally do that too. And I think that would probably comparable or lower costs than the warm board would be my expectation, depending on your labor and the complexity of the system. Compared to baseboard, I would say the baseboard is less expensive for sure. You're kind of the install. It's hard to beat, having some long lengths of a thing that sort of mount, and you clip the hydronics on one side. That's going to be a per beat to you, just by virtue of the material and installation. However, then you're looking at a thing. You have to like how that looks. You have to consider floor planning and anything that's pushing up against that wall and all those issues that have plagued baseboard, panel emitters for a really long time around the couch blocks it, and then you get, you lose 50% of your heat output, and the room is always chilly, and your couch is warming up, and like, all right, well, you factor that in over time in operating costs, and like, yeah, that's real. But yeah, no, this is not the cheapest way to deliver heat, but I would say it is the most comfortable and effective and lowest energy approach that I can imagine. I would do it in a heartbeat again. I was really, really happy with it. And we're actually looking at least one and potentially another project where radiant ceilings are definitely on the table for us.
I have been in a number of meetings on multifamily projects where I have said, you know what, you might want to consider a radiant ceiling, because you can start off with a boiler, and then after the boiler kicks it in 15 years, you can, heat pump technology will be far advanced of what it is now. And we're talking with air to water COPs of, 4, and we're probably going to be at 6 at some point in the not too near future. And I'm like, once you have the radiator in, you're good. And you can, have you done any cooling with it?
Yeah, so I don't know if we actually said this out loud, but it is an air to water system that's powering that building. And we are doing cooling. We are doing cooling in 2 of the bedrooms through a small fan coil system. So I am still not comfortable in residential construction where people like to open their windows in a hot, humid climate like Vermont, or at least during the cooling season is quite humid, running the risk of condensation and having cool surfaces.
Right.
I'm just not comfortable with that. I worry too much about condensation and associated mold risk. So we're not doing any chilled surfaces right now. If I could really guarantee that this was going to be in some sort of like static office building where I could really guarantee ambient temperature and humidity control to within a precise enough degree, then I'd feel a lot more comfortable around chilled surfaces. But what we do in this building is a separate cooling zone that when the system is in cooling mode, the heating zones lock out and it's just the cooling zone, and that runs a loop of chilled water to a fan coil that's in the basement, a ducted fan coil that then sends to some ductwork that branches and sends cooling service to 2 of the bedrooms. And we're looking at maybe expanding that to the rest of the house. And that's been a huge piece in mechanical design in our work in the last 5 years. It's gone from like, oh, if you have a high performance building and a relatively flexible client, then you really don't need cooling in Vermont. And that's really changed to,
you need cooling in Vermont.
You really need cooling. Like you got to plan that there were going to be periods of time where even like a high performance building with flexible clients are going to be like substantially uncomfortable for like extended periods of time in their home. And, I don't think we're at the point of risk to, survivability or like significant health impact on the cooling side as we have on the heating side, or as we see like, in out west, and some of the, the real health risk that comes from underserved cooling systems like they've been suffering from in the Pacific Northwest, where their infrastructure is also not designed for cooling loads, and they've really been suffering. We're not there yet, but I absolutely expect that within my professional career, we will have some heat dome events that are going to result in significant injury or loss of life in our region as a result of lack of cooling infrastructure. So it's moving for me mentally from the point of luxury to the point of like actual necessity as we move into the next part of this century.
I think you're absolutely right. I am not designing, and actually have not designed any of my houses that I've helped design or been consulting on, leaving cooling out of the mix, just because it's getting warmer, and we're having these extreme events, and just because we haven't seen one here recently doesn't mean it's not going to come. And as the if you track, one of the things I like to track, I'm a weather geek. What can I say? I like to track the jet stream and how it looks. and the jet stream is looking like spaghetti, and it used to just look like this,
Yeah.
and
Uh-huh.
that's causing a lot of these extreme events, and we're not going to be able to be designing houses. I am interested in seeing, and I could completely agree with you on the condensation risk of surface cooling. I'd like to see a robust monitoring system that ties into the radiant cooling and says, okay, if it is this humidity and this air temperature, then the maximum we can cool this water down to, and not with the safety factor and not get condensation, is this. And of course, when you're dealing with a radiant sealing system, you're not just worried about the condensation on the surface, but there are minuscule air gaps around your tubes, unless you've decided to mud the whole thing, which is one of the options to increase mass and things of that sort. But you could have condensation inside your wall and inside your ceiling.
Absolutely.
And that's
let alone all the distribution pipes that are going back to the unit, and whether or not those have really been
insulated,
insulated and sealed.
Yeah. Well,
and that's the thing to be.
No, go ahead.
I mean, that's what makes I get really nervous on our collective behalf as an industry, as we're like, oh, we need more cooling solutions now. Heat pumps are great. Heat pumps provide cooling services, and there's a jump in both the design and the implementation or sort of installation of these systems in terms of quality control for cooling that just isn't there with heating. Like, you have to worry about condensation issues on the heating side. On the cooling side, everything matters in terms of whether or not those pipes have been insulated and sealed or not. And I've heard dozens of cases of weird water stains in people's closets and random spots and funky mold situations because they didn't insulate and seal the cooling lines or the cooling ducts. I see that in ducted heat pumps where they just the ducts haven't been insulated and sealed all the way up to the register, and you get condensation inside walls and it breeds mold and creates really unhealthy situations. And like, that's really scary because I don't think that's on our radar. On the design side, designing for cooling loads is non-trivial. You really have to think about latent loads now. And there's this whole other host of inputs. You don't have to, there's no latent load on the heating side. So you do a UA, you add some infiltration, you leave a safety factor, and you're done. Not so with cooling, and solar gains are a really significant issue as well. So there's more siting and building form, window layout and orientation that like now mechanical design folks have to be thinking about. And then the other thing that really worries me is the turn down ratio on heat pumps.
How low can they go? What's the
for
minimum?
Cooling sides? Like, it's a problem. Like, if you're designing your heat pump system expecting it's going to provide both heating and cooling services, your cooling loads are 25% of your heating loads, and you only have like a 3-to-1 turn down on your heat pump, you're going to have some really inefficient cooling that is not going to do a good job of dehumidifying the air. And so you're going to have, and not going to, you do, like I see, like this is a problem. We have buildings with sort of damp, dank, kind of clammy air with a COP of not good because the
significantly below like the
2 to 3 times the size of what the cooling load is because we just threw in one heat pump to do all the things. So getting back to the radiant sealing air to water heat pump hydronic piece, the thing I get really excited about air to water hydronics is that, there's now a hydronic system
buffer
that can also provide cooling, which is freaking awesome. For those of us in the hydronic world, it's like always the big thing. It's like, it only does heating, paying all this money for this like amazing heating system, and it doesn't do cooling. Air to water will do cooling. And if you've got this buffer tank of fluid, there is no turn down ratio issue. You can have a heat pump runs at its ultimate max efficiency, and then you have the super insulated tank with like negligible standby losses, and the cooling load can just sip off of that as it needs to. And so from a design and efficiency, efficacy, exergy, and comfort standpoint, I'm like, that's it. Air to water with heat pump. And I like what you're saying around having some monitoring for some chilled surfaces. And then just be able to have some alternate control logic if the humidities inside the building are large.
Exactly. Yeah.
I think that's the next evolution as we've got, especially as we have smarter controls and better monitoring capabilities that don't cost thousands and thousands of dollars to get that information. And like, we could actually control for that. And
We
do
could
that.
actually have, surface temperature monitors and air monitors telling the thing,
Yeah.
change the temperature you're sending, and
Yeah.
keep a safety margin of this. And yeah, that as the engineer, that's the first place I go. Let's try.
Yeah.
I think it's a beautiful system. I'm going to be installing it over at 10 Old Stage, which you have graciously enough come by a couple of times to take a look at. And we'll be doing full install videos on that system and the choices that I've made. And of course, Jacob, I reserve the right to pick your brain about this into the future.
Pick away. I love talking about this stuff. It really is exciting. I'm not generally, as someone that does like all the mechanical either design kind of administration for new frameworks, even with that, I tend to not be a super techie kind of a person. It's not really my bag to like go straight to technology as a solution to a problem, but this is a pretty sweet piece of technology to have in our hands, the ability to do hydronic heating and cooling. And then as the sky's the limit on the distribution systems, but I'm psyched to see what you come up with for your ceiling design and help support as I can.
Well, I will certainly make sure that you're in on the loop on any questions that I have, and when we actually do the install, I'll have a couple of open days to have people, because everything that I do is an educational opportunity for someone, if not just for me, then for hopefully other builders who are saying, I think that's a horrible idea, and then come out and say, maybe this isn't such a bad thing. And if we can get a couple of companies making large volumes of the panels that can just click up and you can install them, then we can get the pricing down and get our HVAC techs used to this type of system. But I think I really like your fan coil cooling solution. That's a great way to protect you from the possible building durability issues and still be able to provide cooling with reasonable distribution losses. So I think that's a pretty cool solution as well. Of course, added cost. It'd be nice not to have to add the fan coils, but
exactly.
But what do you do?
Exactly.
You gotta provide a house to someone that they can actually use. We can't make these things like the Starship Enterprise and expect normal people to be able to run it. We've got to make it something that is that most of the stuff is being dealt with passively, like you said. I recently was doing a design, and there was a large overheating issue, and the client, who's a designer, said, I found these great screens that you can clip into the window instead of a regular screen for keeping bugs out, and it reduces the solar gain by 87%.
Wow.
It's one of those kind of things that has a lot of little holes in it, so you can actually see through it, so you can see outside, but because it's outside of the window, and it's not something you have to put in and take out every time you want to use it, you just leave it in place. It's got a very high ability to reduce the solar heat gain. So
that's
also another interesting one last technology on the cooling side. There's a team at Carnegie Mellon that developed a new type of white paint. This white paint also reflects ultraviolet and infrared light, so the surface temperature of the paint is lower than the ambient temperature, even when full sunlight is on it. So who knows how long it's going to take before a gallon of that is available? But imagine painting our houses with a paint that automatically cools itself. That's something that I'm really excited about too. Okay, well. I'm sure that we could find another topic. I've had you sitting here for 2 hours. I appreciate the serial episodes that you're willing to go through. I will Back on. Hey, there we go. I'm getting the hang of this. I hope you enjoyed that that video of Deva Racusin. Once again, I will be taking the video itself, and I will be posting it as a separate interview video so that you can just watch that video or any of the videos. The interview with Katrine Klingenberg we did and posted 2 weeks ago was also super fascinating. Once again, Glavel days, open days at the with tours at the Essex, Vermont Glavel factory the week of the 13th of September, so the 13th through the 17th. Put that on your calendar. Or certainly let all of the members of the Home Builders and Remodelers of Vermont Home Builders and Remodelers Association. I don't have my hat with me. I left it upstairs. I exchanged it for this for my 20th. My son's 20th birthday. My wife and I dressed up like Mario, so it's a lot of fun. Okay, next week we're going to be looking at workforce development, and hopefully the week after that we're going to do a deep dive on blower door test, what it is, what it isn't, and hopefully we'll have the famous Dave Keefe, formerly of Efficiency Vermont, and an expert on the blower door. He's the guy who started out with the knobs, right? He's back in the 80s when these things were first brought out. Yeah, physical manometers, yeah, instead of what we have now, which is awesome technology, makes it much easier. So until next week, please, if you have any questions or want to ask us a question or talk to us about a project, you can email us at housecallsvt@gmail.com. Yep. Yep, yep. I'm sure we'll have more than enough time to get that production, that bit of the production done. So we will have video of a house that we're going to pressurize while it's full of smoke and watch where it comes out. And so the crew and the builder himself are all very interested in seeing how that turns out and when we share it. R&B, everything's R&B. Okay, everybody, this is Chris West. Thank you very much for joining us. Until next time, bye.